Okay, so this is one example of a field map. So here you kind of have a regular EPI image that's been acquired with the distortions going in a certain direction. So going from posterior to anterior. That's explained in this part of the bit specification. So when you have multiple phase encoded directions, so in the open Euro case, this is going from posterior to anterior. It's likely that the fMRI or the diffusion data have been acquired anterior to posterior. So what you can do is you can use these two field maps with different directions. And because they're warped in opposing directions, you can use that to estimate what it would look like without any warps. So let me look for another data set that might have some Siemens style field maps.
Ooh.
So here's an example of what a magnitude image looks like. And we have two magnitude images and one phase difference image. So this is the difference in phase between the two. And what happens if you're using something like fmriprep is it'll take this image and it'll use it to estimate a field map from here. So in our data set, it looks like we have the two different types of field maps that I showed you. One is the Siemens style field map, and that's these three scans. So a magnitude 1, a magnitude 2, and a phase difference image. And the other one is an EPI image with that's been acquired in the anterior to posterior direction. So the first thing I'm going to do is I'm going to convert the Siemens style field maps. So let me sub01 underscore magnitude 1.json. I think that might be all we need. Yep. I'm going to do the same thing for the Nifty. I also want to do for the magnitude 2 image. And finally, I'll do it for the phase difference image.
One thing. So I see a request for the code you're using today. So do you just want to pipe your history into a file?
I'll do that.
Cool.
And the last thing I'm going to change is the two EPIs. So for those files, so for this example, the required fields are the subject, the direction, that's what's going to be used to differentiate the two scans, and the _EPI suffix. So I'll start with the first one. the direction is AP. And same thing for the ni.gz. And then lastly, we're going to do it for the other direction. So now the other thing, it's not mandatory for the bid spec, but if you're using a pipeline like fmriprep or something, it needs to know this information. So there's this intended for tag in the JSON that we can add. And this is what different pipelines will use to figure out which scan you want to actually apply the field map to. So we'd be looking at the diffusion scans or the bold scans, or the fMRI scans, and seeing which one to apply it to. So it looks like, I guess the best way to do it is to do it by series number. So in this example, the diffusion scans are the 18th and 19th scans, and the fMRI scans are 5, 6, 7, 8, and then 13, 14, 15, 16. So it looks like for our field maps, the field maps that were acquired in 2 opposing directions were 3 and 4. So it's likely that these apply to these scans, like the BART task and the REST task. And the phase difference scans were scan 11 and 12. And it's likely that those would apply to these other guys, the other BART and REST scans. So you want to choose field maps and fMRI scans that pair together that were acquired at similar points in time, just because the field map can change if the person's head moves. So yeah, you want to try to capture the intended for field with scans that were acquired close in time. So before I do that, let me just rename these DICOM files. I'm going to try doing this in like a bit more of a programmatic way. So let's go back to the bid spec to see how diffusion scans are acquired. So we have the subject label, and because in this case we have 2 different directions, I'm going to use the dir label and then underscore d.i. So underscore dir is going to be AP, underscore DWI. Forgot the semicolon. Oh, I think rename works differently on Signet, or it's like a different rename. Yeah, I'm just going to rename one of these fMRI files just to show you how we would add in the intended for field. So for fMRI data, we have the task label. And then in this case, because we have multiple of the same scan, I'm just going to add in the run tag as well. And that'll help us differentiate different tasks. So now that we have one of our fMRI files renamed, I'm going to add in the intended for field in the phase diff JSON. So let's go to the end. Add in intended for equal to. So here we can also add multiple files. You don't have to add just a single one. Oops, the task was actually BART, not Rust. The next thing that the phase difference file needs is the echo time 1 and 2 fields. So usually these are split between the two magnitude JSONs. So what we're going to do is add them in. So first I'm going to figure out what the magnitude file is for the, or what the echo time is for the first magnitude. And grep for echo time. And then I'm going to do the same thing for the second JSON. And there's two ways we can add. So we can add these two echo times into the phase diff JSON. And there's two places we can do it. We can either do it directly within this subject JSON, or we can do it at the top level. So I'm going to actually do it at the top level. So we can create a phase diff JSON file. And the way BIDS works is through the principle of inheritance. So if you have a phase diff JSON at the top level, any tags that are associated with it will trickle down to all of the other phase diff JSONs underneath it. So here I'm just going to add echo time 1, 2. Oops. I forgot what they were. Okay, 492 and 738. And these fields, the echo time, are important for actually creating a field map image from the phase difference image. Usually we do the same thing for the fMRI scan. So one of the requirements of all of the fMRI JSONs is to include the task name in them. So instead of having to include the task name in every single fMRI JSON, we do it at the top level. So it'll apply to all of them. So call this task BART full.json. And I'm just going to give this the task name as BART. And I'm just going to remove all of the things that I didn't convert, just that we can test out the bids validator and see if what we've done so far is valid. So it looks like there are a couple problems. For one of the scans, it's not 4-dimensional. So maybe this was actually meant to be a field map, but it was in the wrong place. The other issue is the slice timing is weird. So yeah, sometimes you might have issues during bids conversion with your slice timing. I think Aaron might be able to speak more to slice timing, whether you want to use it or not, or just completely get rid of it in the tags.
Yeah, it's an area of controversy, whether or not it's actually slice timing correction actually does anything. But the key here is that if you want slice timing correction to run in a bids preprocessing pipeline, then you need this slice timing field to be correct within the JSON. It's not something you can edit and add elsewhere, I guess is all I'm going to say.
Yeah, the other warning we get is that for any task fMRI data that isn't a resting state scan, the bids convention uses a TSV file that kind of explains that kind of is a spreadsheet containing the timing of the task and when different events happen. So it's a good idea to include this during bids conversion, and then you won't have to worry about it. And it's also a good way to kind of explain what's going on in the task, and then you can programmatically analyze it that way. So I'm just looking back at the questions, and Alyssa asked the difference between the B0 map and the reverse phase encoding B0. So yeah, they do ultimately serve the same purpose. I think nowadays people are gravitating towards the reverse phase encoded B0 just because it seems like it tends to be more accurate at undistorting the image. You can think of like when you have two scans with different directions of distortion, when you kind of cancel each other out, you can arrive at an undistorted image much easier. And Katie was asking if it's possible to append the intended for field to the JSON through the command line. And yeah, that's a good question. I'm not really, so I typically use Python for this. I'm not sure how you do it in Bash, but the way you do it in Python is you can really easily read your JSON into a dictionary, like you saw earlier with the PyBids. And you can add tags to that dictionary and write it out to a separate file. So the way I would suggest doing it is if you're reading in the field map JSONs, you can just kind of glob for all of the fMRI scans that exist, and then write it out to the intended for tag. I think if you also want to use, this gets a little bit more complicated, but if you also want to use the hue deconv or DCM to bids converters that people have already created, those kind of have a way to do that for you to write out the intended for tag. But yeah, if you don't write it out, I think at the moment fmriprep will not do distortion correction. But I think in the immediate future, what they want to do is read in what type of field maps you have by nature and kind of create a priority list. So like if you had the reverse phase encoding direction field maps that do a much better job, and even if you don't include that in the intended for field, it'll use it. Because I think a lot of people have kind of gotten frustrated with having to add the intended for tag, because I think that's probably the most difficult part of bits conversion, being able to accurately determine which scans you need to add there.
So we reached 2 p.m. So we might call it in for today. The assignment can go in the assignment Dropbox, and tomorrow we're going to be speaking about containers and data lad and preprocessing and all of that exciting stuff. Any final questions before we call it quits today?
I think right now we have a description of what the assignment is on the HackMD file.
Oh, sorry. Okay, two things at once. Yeah, I will copy the assignment into the website.
Oh, okay, cool. Yep, I mean, you're fine to submit just your command lines. It doesn't have to be a fully functional script, because I know it's only a day to kind of get this done. So yeah, even if you wanted to just submit a text file of your command line arguments, that would be perfectly fine. Cool. Thank you everyone for joining. And I guess we'll see you tomorrow to talk about running containers, debugging containers, and then using some common kind of containers that people use like fmriprep and mriqc that we've been talking about a lot over the past 2 days.